You've probably been there, right? That meeting where everyone's arguing about whether a system's design is good or bad. It's one of those classic debates in our field. Well, today, we're going to cut through all that noise. We're going to dig into a set of rules and principles that can actually help us figure this out and, build better software. Let's jump right in.
So let's ask the big question right up front. What really makes a software architecture good? Is it about using the newest, shiniest tech? Or maybe it's about being incredibly complex or super simple? Well, it turns out the real answer is none of those things.
And boom, here it is. This is probably the single most important idea we're going to talk about. It really shifts your perspective. The quality of an architecture isn't some absolute thing you can measure in a vacuum. So the takeaway, we need to stop arguing about good versus bad and start asking, good for what? It's all about being fit for a specific purpose.
Let's make this super concrete. For a big business-to-business system, a standard 3-tier architecture is great. It's a perfect fit because scalability and maintenance are what you care about. But now imagine taking that exact same architecture and trying to use it for an airplane's flight control system. It would be a total disaster. Why? Because the purpose is completely different. In avionics, you need instant, real-time responses and insane fault tolerance. That's fit for purpose in a nutshell.
Okay, so how do we actually make our architecture fit for purpose? We're going to break it down. We'll start with the process rules. That's the how. Then we'll get into the structural rules. That's the what. After that, we'll lock it all in with some core definitions. And then, at the very end, I'll show you how you can apply all this stuff yourself.
All right, first up, the process rules. I find this part fascinating because we often focus on the final blueprint, but how you actually get there is just as critical. A brilliant design on paper can totally fall apart if the process is a mess. So let's see how to get it right.
Rule number 1 takes aim at a classic problem, design by committee. You know what happens? When you have too many cooks in the kitchen, you end up with a disjointed Frankenstein's monster of a system. Having a single architect or a small, focused team means you get a unified vision and a coherent design from beginning to end.
Now this one is absolutely crucial. You have to prioritize. You just can't optimize for everything at once. So let's say military-grade security is your #1 priority. That single decision is going to shape everything else. Your tech stack, your data flows, the whole shebang. But if blazing fast performance is #1, well, that's a completely different road. You've got to know what you're building for.
An architecture isn't just one diagram. Think of it more like a story told from different points of view. A developer, they need to see a detailed component diagram to see how the pieces fit together. But the CEO, they couldn't care less about that. They need a high-level overview that shows how the system helps the business. A great architect knows how to create the right view for the right person.
This is all about catching problems before they blow up into 5-alarm fires. Think about it. Finding a performance bottleneck when it's just a drawing on a whiteboard, that's an easy fix. Finding that same bottleneck after the system is built and running for thousands of users, that's a crisis. You got to evaluate early and evaluate often.
This here is the cure for the dreaded Big Bang integration. Instead of everyone building their part in a silo and then trying to smash it all together at the end, which, let's be honest, never works, you do it differently. You build the core skeleton of the system first. Then you add one piece, integrate it, and test it. Then the next piece. This way, the system grows naturally and you catch problems while they're still small.
All right, we've covered the how with the process rules. Now let's switch gears and talk about the what. These are the structural rules, the principles that help you create a foundation that's solid, flexible, and built to last.
Think about the dashboard in your car. It gives you a really simple interface, right? A steering wheel, some pedals, a speedometer. It completely hides the incredible complexity of the engine and the transmission. That's information hiding. Good software modules should do the exact same thing. Handle one job and hide all the messy details from the rest of the system.
Oh man, this one is huge for future-proofing your work. If your entire system is hardwired to, say, version 2.1 of a specific database, you are in for a world of pain when that version gets old or a big security flaw is found. A good architecture puts a layer between you and that tool, making it way easier to swap it out later without having to rewrite everything from scratch.
Here's a perfect example of this in action. You've got a network of weather stations. They produce data. And you've got a weather app on your phone. It consumes that data. By keeping them separate, you can completely change the hardware in the stations or totally redesign the app. And as long as the data format in the middle stays the same, nothing breaks. That's what a modifiable system looks like.
This one is all about being flexible when the system is actually running. So imagine you have a background job, like rendering a video, and it's starting to slow down your main server. In a well-designed system, you can just reconfigure it to run on a different, more powerful machine. No code changes needed. That's how you scale efficiently.
The big word here is consistency. If some of your components talk over REST APIs and others use gRPC and a few others just write directly to the database, you've got a tangled mess on your hands. But if you establish a small, consistent set of rules, like all services talk to each other using this type of API with this kind of security, the whole system becomes predictable, reliable, and way easier for new people to understand.
Okay, so we've walked through the rules for both process and structure. Now, let's just take a moment to make sure we're all on the same page by locking in a few of the core definitions that all these ideas are built on.
So let's get formal for a second. What is software architecture? The key phrase to notice here is the set of structures. It's not just one diagram. It's all the different blueprints combined. The component structure, the deployment structure, the data flow structure. You need that complete set to really reason about things like performance, security, and all those other qualities we talked about.
So if the architecture is the whole collection of blueprints, a structure is just one of them. For instance, a diagram showing your microservices and how they're connected by API calls, that's a structure. It's a map of specific elements and how they relate to each other, which helps you analyze one specific part of the system.
And finally, a view. This brings it all together. A view is just a presentation of a structure that's tailor-made for a specific person. Remember our CEO and developer? They need different views of the same system. A security expert gets a view that highlights firewalls. A project manager gets one that maps features to components. Same system, just different ways of looking at it.
Okay, we have covered a ton of ground, the rules, the definitions, the whole works. Now, to wrap things up, let's turn you from a passive learner into an active critic. I'm going to give you the one question that will help you do just that. So, I really want to leave you with this. It's a powerful tool. The next time you're looking at an architectural diagram, don't just focus on what's actually there on the page. Ask yourself, what is this diagram not telling me? Does it tell me anything about performance under heavy load? Does it explain the security model? Can I tell how we're going to maintain this thing 5 years from now? Asking what's missing, that's the real secret to figuring out if an architecture is truly fit for its purpose.